Hello everyone, this is Matt from the DeLINEATE toolbox and the University of Nebraska-Lincoln. Here where we have just set up a new workstation for doing some deep learning stuff as well as general data analysis. So before things got too crufty, I thought I'd take this opportunity to use this as a model to show you guys how you might want to set up your own such workstations. So this is Bender, as I might have mentioned in other videos. All of my lab's computers are named after Futurama characters. So here's Bender, our newest member of the family. Has a cool clear side case. This is a pretty, I think, everyone's needs will vary, but I think this is a fairly typical build. Nothing too crazy, but pretty nice GPU inside. So I'll give you a quick tour of the hardware, and then we will jump ahead to the software setup and all this stuff. So it's a pretty straightforward tower configuration. I can post all the model numbers and everything on our site if you are so inclined. We're basically kind of a standard, generic case. Whatever let's see, I think the motherboard is an Asus Prime Z370, but we weren't too picky about the motherboard. We just got something that would accommodate all the hardware we have in here. I know the case cover is kind of reflective, so it's a little hard to tell what stuff is. Actually, maybe I will quickly take that off so you can see a little bit better, so hang on. Okay, so here we are back again with Bender's side panel taken off, so it's not quite as reflective. So here he is. We custom built this because we just wanted to get it exactly right and because it's probably a little bit cheaper going that way. But of course you wouldn't have to. You just have to build basically a PC with a pretty good processor and a pretty good GPU and as much RAM and storage as you feel like you're going to want. And for us, we figured we'd just take the opportunity also as a kind of educational experience for my lab members to see how a PC was built. We just kind of did it ourselves from parts. So that's what we did, but you could do it however. The key ingredient, of course, to doing deep learning stuff is your GPU, and we went pretty nice, but not super crazy. We got a GTX 1080 Ti, as you can see. I'll put like the official parts list or the actual parts list somewhere in this video comments or on the website, but I forget the exact retail for this, but I think it's $700 or $800 US at this time. So not crazy, but definitely the biggest single line item in the build. The other thing that's pretty expensive, of course, is our CPU, which you can't really see because it's behind this heatsink, which I did not realize when we bought it would be enormous. It was just whatever was cheap and well recommended on Newegg, which was one of the main places we got our stuff. So you can't see the CPU back in there, but it's a pretty recent Intel Core i7. You wouldn't need to go totally crazy on the CPU if you're planning only on doing deep learning analysis, because most of that is done on the GPU. But if you're doing other kinds of analyses that are CPU bound, like conventional MRI or EEG analysis, or if you are interested in doing MVPA stuff that is not GPU-ified, then that would be a good thing to have, like at least one CPU with a bunch of cores, which is what we ended up going with. I think it's a 6 core, I believe, is what we ended up going with. Okay, so moving over here, just ignore our kind of fancy looking lights. Those just came with the motherboard. We did not request those specifically, but we've got our RAM over here. We put about exactly 64 gigs in here. It also looks really weird and fancy because a lot of this, high-end stuff is made for gamers, but this was just the RAM that was compatible with the system and was cheapest at the time. So there's our RAM. And in terms of storage, you can't really see the hard drive, which is kind of buried in the case. But we also put in, what you can see down here, a 1 terabyte SSD. So storage-wise, we put in a terabyte SSD and a 4 terabyte conventional hard drive for bigger data sets. You can do whatever you want to do, but that should fit our needs pretty well. So that's our major build. Nothing too fancy or weird in it. So at this point, I will go into put the case back together and go into the software setup and walk you through a little bit of that. Okay, here we go again. I got the case all back together. I'm going to go ahead and do the OS setup here. I'm not going to make you guys watch the whole thing, but I figured I'd get a little bit into it and see how far we go. This is my kind of jury-rigged little monitor setup because we don't yet have a proper monitor. We had some lying around that didn't have an actual stand though, so I'm just using that for the time being. And I'm just going to go and hit the on button here. So what we tend to use for our stuff is Linux. you know, if you do heavy data analysis, oftentimes you find yourself using Linux. I'm hitting F2 right now to enter the setup, the BIOS for booting up, because technically there is an OS on this system because I've already, I've already done this once with this system, but actually, you know what I'm going to do? Hang on a minute. Okay, sorry, I just had to flip the phone around so I didn't get my finger in it. Looks like it has lost all of our information on what time it is, but that's okay. So here's our BIOS setup. Of course, it's going to look different depending on who makes your motherboard. But yeah, so I've already installed an OS on this before, but let's pretend I didn't. We're setting this up fresh. So you might need to tweak some BIOS settings on whatever system you set up, but what I'm mainly going to do is just go into the boot menu, because I've already done that stuff, and just say that I'm going to boot from the optical drive. So let's see if I can get that. Okay. So, at least on this particular system, if you guys have ever installed Linux before, you may have found that it's a little finicky, but you know, that's the price we pay for the free software and all that stuff, I guess. So we tend to use Ubuntu for everything. Let's see, I'm going to install Ubuntu. We're still using 16.04 right now, a long-term support version. That's what we've got everything running on. I didn't bother to put an optical drive in this machine, so I've just got like a USB optical drive, because about the only time I ever use it is when I'm installing an OS from the OS install disk. And so this will start up the OS installer. Again, you can probably figure out putting an operating system on your computer yourself, but I figured this would give me a chance to talk about a couple of the things that we do, and then pretty much everything else I do after the first couple steps will be done remotely, which is how we usually log into our workstations. One thing I will note is that I didn't mention this earlier, but we've got the graphics card down here, but I don't have the monitor plugged into that. I have the monitor plugged into the onboard graphics, so we made sure to get a system that could do onboard graphics, you know, with the what you can do with the right CPU and motherboard combination. And the reason was you can do deep learning on the same graphics card that is driving your graphics, but generally speaking, I don't know if this is a universal experience, but generally speaking, I find it easier to just pretend like that GPU does not exist as a graphics card and use that GPU exclusively for computation, and that makes our lives easier. So that's what we've been doing for this, is we're only going to be plugging our monitor into the onboard graphics and just using the GPU for computation. So I might pause this for a bit while the OS installer loads, and then come back to you once it's showing something a little bit more interesting than this waiting screen. Okay, so here we are a few minutes later, having booted into the OS installer. Again, I think you guys can probably figure this out yourselves, although having done this many times myself, I can tell you that you know, each new system is its own special little snowflake in terms of the weird things that can go wrong, you know, interactions between the OS and the hardware and the BIOS and all that. But that's for, you know, the other parts of the internet and the Ubuntu forums and lots of Googling, and because you know, unless you replicate our setup exactly, you are probably going to have different situations. But I'll take you through, you know, the basic steps if you've never installed Linux before, and just talk a little bit about the setup for the deep learning systems. One thing I'll note is I do have this hooked up to the internet. Don't worry about why I have it going through a little USB thing up top instead of through the Ethernet jack on the back. That's a weird hack to get around some of our internal networking nonsense. But anyway, it helps to have a network connection. One weird feature of the Ubuntu installer is you better have it hooked up to a network connection before the installer finishes booting, because it won't give you this chance again if you go to this next screen. Because I usually turn on the option to download all the optional updates and third-party stuff while I am installing the OS. I can't prove that it makes any difference doing this before or after install, but I've never not done this, so I think that's probably a good way to go if you want to get the latest and presumably least buggy versions of everything. Although there's still updates to install once you reboot the machine when it's done installing, so I don't technically know if it's actually doing anything different, but I still do it anyway out of hope and superstition, I guess. Okay, so it should just be a couple more steps actually before the OS starts installing. So yeah, you can see here that I have already installed Ubuntu before. We're going to pretend I hadn't. If you had just a blank disk inside, it would give you a much simpler set of options, which is basically just like install Ubuntu on your blank disks. But I'm going to tell it to erase my disk, and of course I'm going to tell it to install everything on my faster 1 terabyte SSD. It will erase all the partitions on that, which is fine with me because, you know, I'm ready to put just a bare OS on there, and then I'll do all the other configuration myself. So that just warned me. We are in Central Time. We're, I think, kind of right about there. It doesn't really matter, but here we are. Okay, keyboard is English. All that stuff is pretty trivial. All right, let's see how well I can do this while also doing this. So as I said earlier, the computer is named Binder, so that's what we'll call it on our network here. Oh, my password. Oh, you don't want to know my password. Hopefully, it'll be fine. Nobody can get into these, hopefully, except people in our local network. So I'm going to go with a pretty short typable password for now. All right, and all that's fine. So I think that's pretty much all we need to do setup-wise, and then it's just going to go for a while. And then if all goes well and nothing crashes, I will see you guys on the other side when we're ready to do a little bit the actual configuration that you probably care about. So sorry if you didn't want all this other detail, but we'll get to the actual deep learning setup soon. It's a little bit of an ordeal, but we have more or less perfected the process, I think, at least for our systems, and hopefully your experience will be similar. So if you stick close to what we do, you probably should be okay. I like to flip this little sucker down here, although it'll take a second probably, just to get all the details of the copying. But anyway, so if all goes well, this will just sit there and install files for a few minutes, and at the end it will say, okay, your OS is all installed. Now reboot the computer. One thing I will note, if you have not installed a lot of Ubuntu in the past, I'll just give you a little pro tip. It always says, like, eject the install disk and then press enter to reboot, and leaves you on a screen that says that. I have never in my history of installing this operating system have it successfully process when I hit enter to make it reboot. So I always have to, you know, just take the disk out and then cut the power to the computer entirely, because it never seems to recognize that key press correctly. So anyway, if it gets to that point, do not panic. That's what always happens with us, and it seems like it's always been okay. So anyway, with that, I will let it do its thing for a few minutes, and then I will catch you guys on the other side when we have hopefully rebooted to our freshly installed operating system. Okay, so good news. The installation looks like it completed successfully. I've taken off the CD drive, so now we're just going to start our brand new Ubuntu system up, and hopefully we'll be in business. Like I said, there's just a couple steps that we have to do kind of in live interaction with the system, and then as long as we're connected to the network, I do everything back from my own workstation back in my office. So I'm just going to configure those first few steps. One thing, so you guys, I guess, will get a little bit of a tips and tricks we've learned about Ubuntu in this, as well as the actual deep learning stuff. Well, let's see if it's ready to get my password. Okay, it's still thinking. It is a pretty quick boot up off this SSD, which is awfully nice. Let's see if it's actually ready for my password now. All right, I might have to pause and come back if we're hung up here. I'll just give it a second. I'm going to cut the recording off and then try that again in a second. Okay, we're trying this again. I don't know how I'll cut this together, but we had a little bit of a glitch on the last startup. It just seemed to freeze on this login screen, but it looks like we're okay now. So, I just had to power down the computer and start it up again. This is not uncommon when you're working on a new Linux system. If you've ever done this before, it gets a little bit, you know, just gets a little bit confused sometimes. But usually once you've got everything configured and updated and everything, then life is pretty stable. The trick is just getting everything into a stable configuration in the first place. Okay, so one of these things that is a little unstable, and that could have actually left the crash, I don't know, is if you try to install any software from the command line, how I like to operate, or just in general, one of the things that will quickly happen in this version of Ubuntu seems to be that we'll have a crash with some process that seems to have developed in some kind of fatal issue in a semi-recent update. So by that logic, Maybe I should not have ticked that download updates checkbox when I was installing, but who knows? Maybe I'm saving myself from bigger issues also. So anyway, the way that we found to get around this is to basically keep updating, and once you get through another round of updates, the thing that tends to crash will not crash. So I'm going to go ahead and do that now. Basically, if I, oh, there it goes. Okay, yeah. So the sort of tricky issue here is that the thing that keeps crashing also prevents you from running the package manager that I would normally use to install updates from the command line. So I'm just going to put my password in here. Whatever. Okay, yeah. So fine. I mean, I'll report the problem. Why not? But that's not really going to make a difference. This will probably come a few more times. Unfortunately, it's this like apps. Well, there's a couple processes that have issues, but one of them is this AppStream CLI thing that, as I found on the internet, a lot of people have the same issue when they first set up a system. Anyway, so the way to get around this, because we cannot do our updates from the command line, is to run the graphical update manager, which I just invoke via the command line because I don't know how to invoke it otherwise. I'm just going to cancel these again. And for some reason, I also tend to get a failed notice, even though it then proceeds to actually show me most of the software that I can update. This, again, may be an artifact of whatever the bug is that's causing that other thing to crash. All right, just put in a password here. Okay. And this is just a few updates, so I will try to keep the video live. Sorry for the shaky video, by the way, but I figured we don't need to get too fancy just now. So this is going to install some updates, and then we'll have a quick reboot and install a couple other things, and then we should be good to go to a screen recording with a better microphone and no shakiness for us to do the rest of this setup. So this is just so basically, I like when the system is first set up, what I tend to do is get everything completely up to date. You guys, your mileage may vary, but if I'm doing an analysis machine, or if we're doing like we use Linux also in our stimulus presentation machines, you know, what I tend to do is get everything super up to date, figure out any bugs since the last time I set up a new system, you know, get everything perfectly up to date, and then ideally turn off all updates entirely, because I mean, you know, you do want security updates, I guess, if you're going to leave your system connected to the broader internet, but you know, once you've got everything nice in the Linux world, it's, you know, a lot of us tend to find that it's best not to start touching things, because you run into a lot of version-to-version incompatibilities, some of which you will hear about later on in this process. But lucky you guys, if you can manage to sit through this narration, you will hopefully get a lot of that done for you, because we figured out a lot of the issues in the process of writing this toolbox ourselves. I'm just going to not report these problems. This is going to keep coming up. It'll even come up after we reboot, even though it's no longer having the problems after the reboot. I think it like has a cached, it caches like its knowledge of that error, and we will get one more notification even after the issue is fixed. So anyway, install our updates, reboot, and then basically what I'm going to do once we restart again is I'm just going to install one or two critical packages. Well, actually, I'm going to just make sure we've got everything updated from the command line, and then I'm going to install the SSH package, which is actually not installed by default for some reason. I would have thought it would be, but it is not, and that will let us use SSH to start a remote session from my office computer, and then we'll just use that henceforward. Okay, so maybe I will let you, well, actually, it's almost done, so I was going to say it won't make you sit through the updates, but maybe I'll cut straight to, I'll keep recording, but I'll cut straight to the end, because for those of you that have not used Linux before, this could be a good, quick little tutorial, but basically we're just going to tell it to reboot when it's done, which is pretty straightforward. So talk amongst yourselves. This will be done soon. Okay, so here we are with our updates installed. We are just going to restart now. Hopefully that'll go just fine now. Should start it pretty quickly again. By the way, this desktop you've been seeing that I've been using, that's the default Ubuntu desktop interface that it shows. It's called Unity, I believe. This is probably the last time you're going to see it in this demo because we, for the life of us, cannot get Unity to work when we have like remote login sessions. I've tried many things and I've never figured it out if it's possible. So anyway, we use a different one called XFCE. So once we get the remote stuff set up, we are going to switch over to that. Anywho, so here we are again. Like I said, even though we should have fixed the problem that was giving us this, we're going to get this again. I'm not sure if this, you might have to keep reporting the problem until this goes away. I think I've read on the internet that at least some people had to actually go through and authenticate and send the error logs every single time. Yeah, it's the same nonsense. Okay, fine. Okay, so we should be fine from here on out, and avoid that error. So what I'm going to do now is I'm just going to launch another terminal, and I'm going to do a couple things. So if you are not a big Linux user, a lot of this may look like gibberish to you, but basically I'm, oops, sorry. Got ahead of myself a little bit. So I'm just going to, I'm going to run this apt apt, which I believe stands for Aptitude Package Manager, and I'm going to tell it to basically check for updates to all software. So it has done that. I'm doing that with the sudo, or some people say sudo, command to do it as the system super user. Be careful if you're not a big Linux user. Okay, it looks like just a little bit more updated stuff to install, so that's fine. Be careful with sudo because you can pretty much do anything you want to on the system, including, accidentally erase your entire hard drive or whatever. So do be careful that you know what you're doing when you launch a sudo or sudo command. Okay, so it looks like we have updated and updated our listing of all the software, and we have successfully upgraded all in apt parlance all the software I've installed. So that's great. So the only other thing I'm going to do is install one more package, which is what I started to do here, and that's the Open SSH server. If I've got that package name correct, should do, yeah. Okay, so I'm going to install that. Sure, another 5 megabytes or so won't kill us. And that will basically install the SSH server that will let us do remote logins over SSH, which, if you are not super familiar with this stuff, is a secure encrypted way to communicate with another machine. And particularly, we're going to use it to run a terminal session on my Mac in my office. So I will now log out of here, and I like to just, after I've run all those other updates and everything, just out of mostly superstition, I'm just going to restart one more time just to make sure everything's up and good, and then I will leave it on its login screen and go over to my office and do everything else from my office. So let's just make sure we correctly reboot all the way, which should just take a few more seconds. Okay, there we go. Looks like we are all desktoped up, so good to go. Looks like the network came back up, which is good because I'm going to use that to log in from my office. So bye-bye for now, Bender. I will see you from my office. So here we are, ready to do the rest of our setup. Sorry if this seems like it's taking a long time, but I figure you guys would want to see us walk you through this more visually, and also, frankly, it's a lot easier for us to do this than to write out a whole document, especially because there's lots of weird exceptions and, all that stuff. So, if it's any consolation, it took us a lot longer to figure this all out in the first place. This is, I think, the 5th machine we've set up, and we've got the process pretty streamlined by now to the point where we can do it in a single day with a little bit of debugging and so on. If you get lucky, you could do it even faster if you follow our guide. with whatever tweaks you need to tweak to get your own system set up. But it was, many hours and sometimes days of labor getting those first couple of systems set up and resolving all of the weird hardware and software compatibility issues you run into when you're using a kind of cutting edge software on a custom built system or whatever. So anyway, here we are. I've got a terminal up on my Mac, and I think I've got all the stuff done that should let me, we'll find out pretty soon, that should let me log in via SSH using my Matt username at the machine vendor on our local network. So that's how I do that. Oh, so this machine, this is just warning me that this machine looks like it's changed. So actually just, I want to do this. You guys don't need to see my whole SSH configuration, but basically I'm just going to edit my SSH hosts files. So much for my hope is that everything will work pretty much in one go here if I've got all of my notes right. I haven't forgotten anything, but clearly it's not 100% perfect because I forgot about this part. But anyway, this is just saying that it looks as if this computer has, the computer at this IP address has changed, which is true, sort of, because we just reinstalled the OS. So that's not a big deal. But if you were trying to securely log into a system and it was masquerading as another system, that would be bad, right? So it's just being careful. So anyway, now I deleted the old entry for the previous install of this computer's OS, and now it let me log in. So that's fine. Okay, so now I'm logged in via SSH to vendor, and what I'm going to do first is install a few software tools. So one I'm going to install is Tight VNC Server, which is one of several possible VNC packages. I think VNC stands for Virtual Network Computing, and that's going to let me run a virtual graphical login session on this computer. So, because sometimes you do need graphical stuff, but you don't want to go and sit at vendor, or, you're not in a position to do that, or somebody's already doing it. So I can run a graphical session remotely from my own machine using VNC Server. So we use Tight VNC, but there's several others you can use. And also, I think I mentioned that the default Ubuntu desktop, interface does not seem to work very well for us over a remote session. So I'm going to install this XFCE along with some other packages that I think are necessary for doing what we need to do. And one of them that is very useful is this one that's called Auto Cut Cell. I don't know if that stands for anything or what. But what that's going to let us do is enable us to copy and paste between my Mac and the remote, desktop session on vendor, which is very useful because then I can copy and paste. I could copy and paste text now into my Mac terminal, but once I got the graphical window going, I would not be able to copy and paste until that auto cut cell thing was running. So that's very useful for when you're doing stuff in this virtual desktop. If this makes no sense to you, hopefully it'll make more sense in a second when we actually get it running. But anyway, that auto cut cell is critical for us being able to copy and paste, which will make life a little bit easier in a little bit. Okay, so now I'm going to set up my VNC server. Again, not all this is strictly necessary for the deep learning setup, but it's the most streamlined way I have of doing this on our system. So you'll just have to sit with me through some parts that you may or may not choose to use. So I'm just going to launch a VNC server for the first time. Basically, this is a server for my desktop session. I'm going to enter a password. I use desktop number 27. You basically just need a number. If you have multiple people using your system, you will need to make sure you all pick different numbers so you don't collide with each other. So my desktop is number 27. What I'm actually going to do, and this is a little bit weird at first, you might think, is just going to immediately kill the thing that's running. Basically, what I did that for is to just basically create some of the files that are going to be in this .vnc folder. So just have it create my password and stuff. But now I'm going to go in and edit. I like the Nano editor. It's an easy one. I'm going to actually go in and edit this X startup file. And actually, I'm going to delete basically all of it. Actually, I'm going to delete all of it and replace it with my own configuration, because the default configuration does not work super great. For one thing, it does not have that that XFCE desktop manager. I'm just going to replace the Xstartup with this basically, which I just copied over from a text file that I had open on the Mac side, and then that should be enough to start that XFCE desktop by itself. Okay, so now I'm going to go back into my main home directory, and we should be good to start a VNC server for real. I'm just going to go back up to here, and actually this time I'm going to actually add a little tag to the end, which is geometry, because I would like it to be bigger than whatever the default size is. So I'll run it at 1280 by 800, and that should run a 1280 by 800 pixel desktop, which now I can launch the VNC viewer program. There's various VNC viewer programs. I use the one that's just called VNC viewer. It's, I think, made by the real VNC people. It's free. They have like paid solutions, but the free version is all I need. And I already have a bunch of our machines configured here, so I'm just gonna go into Bender. You might have noticed I had to enter set up a password, but the last time I set this up, I saved the password for Bender in my VNC viewer program, so that's why I did not have to enter a password this time, because it's already pre-saved. Okay, so we'll get this. I will take you through a couple of quick things in this XFCE. You notice that the desktop looks different than the machine did before, but this one also works fine and works seemingly better over remote desktops. There's a couple minor things we need to do to make this thing more usable. One thing is to run that auto cut cell thing. So you might notice, like, if I copy and paste here, I copy and paste between something on the Mac, so just like the word triggers, for example. You know, so I try to copy and oh look, no paste. But if I run, oops, that, I think you have to like recopy something, but here, let's copy that. And now, hey, look at that. I can now copy and paste between my desktop and anything on my Mac, really. I was just using the terminal because that was right there. Okay, so that's one nice thing to do for the setup. The other thing I will do is go into the, this is a thing that plagued us for a little while till we figured out exactly what we had to turn off. We could not use the tab key, and we realized that that's because XFCE has this weird setting that takes control of the tab key. Where is it? Oh, there it is. So we want to get rid of this, and that was for some reason preventing us from using the tab key, which, as you might be able to guess, is a pretty important key when you're writing code and stuff. So now that will let us use the tab key. Okay, so now let us download some of the stuff we're going to need to install to set up proper deep learning. So I'm going to go ahead and run Firefox, which should come pre-installed on the system. Get a nice fresh blank copy of Firefox that's going to give us all these welcome pages and stuff, but whatever. Okay, I'm not going to bother configuring it because whatever, we're just going to go to a couple of different sites. Here, let's see, so let's go ahead and download Anaconda first. So Anaconda, oh, that's probably not enough detail. Let's say download. Okay, so Anaconda is a Python, what to call it, like a Python toolbox or a Python environment. You don't have to do this, but it does make your life a little bit easier to download Anaconda. Basically, what that means is, here, let me get it downloading, then we'll talk about it a little bit. Oh, shoot, I'm not running Windows at all, am I? Let's try the Penguin. Okay, so Anaconda for Linux, I'm going to download the Python 3.6 version. All of our stuff should work under Python 2.7 as well, but Python 3.6 is probably the better move. We already have Python by default on these systems, but this will let us run this stuff. Well, it's, let me just try not to multitask here, and then I'll tell you. Okay, so that's going pretty quick, actually. So what Anaconda does is basically is sort of a secondary, gives you a secondary Python installation that is kept separate from your system Python, which is something that you might want to do if you're using this machine exclusively for deep learning. Then it might not matter. You can just install everything on top of your system Python installation, but if you're using Python for other things besides just the deep learning stuff and the DeLINEATE toolbox, then you might want to kind of have, it's basically kind of a sandboxed or kind of walled off, set of Python tools that don't necessarily interact directly with the main Python installation on your system. And that can be very helpful because we have to do some kind of janky things to make this all work. Okay. So hopefully that makes some sense. So we'll install that in a second, but while we've got Firefox open, we may as well download a couple other things we're going to need, one of which is CUDA, which we're going to download from NVIDIA. Basically, these are the tools that enable us to do computation on our graphics processing unit. Because, normal people use them for graphics, but we use them for computation, so we need to install some special tools. I'm running 64-bit Intel Ubuntu. I'm running 16.04, so that's fine. And I like to get the run file installer. Everyone's different, but that's the one that has always worked for us, and I found the easiest. So let's just save that one. Okay, so that's going to be 1.7 gigs to download. And let's also, for good measure, just go ahead and download CUDNN, which is a specific kind of sub-toolbox from CUDA, or that uses CUDA to do neural network stuff. So these are the basic deep neural net libraries that all of these other things rely on to do their deep learning, right? So it accelerates deep learning frameworks like Caffe, MATLAB, Microsoft's Toolkit, TensorFlow, Theano, and PyTorch. And our toolbox currently uses TensorFlow and or Theano as backends, so we need this CUDNN. You do need, when you download this, you do need a membership to the NVIDIA developer site, but you just click join and put in your email address and everything. Is pretty, I think pretty much everyone gets accepted. It's not the most exclusive club I've ever been in. So let's just do that. And let's see if this works. So everybody gets to see my email address, I guess, but it's not that big of a surprise. Please don't email my private Gmail too much. I mean, you can. I don't reply to most of my emails, so do what you want to do. And let's see. Hopefully this won't show my password in clear text. I think I can copy and paste this out of my Mac password manager. Let's see how that goes. No, I do not need to save that. Okay, so yeah. So I will agree to those terms. I will download the most recent version as of the time of this. And there are a lot of choices. I believe all we need is the basic CUDA library for Linux. I believe that is all I have needed in the past. It's a little confusing, of course, all these things. This is the problem with all kind of like bleeding edge software and everything. None of it's like super well documented, so you do a lot of trial and error trying to get it all worked out. That's why we did all the trial and error for you, and now you get to sit through my narration of this. All right, so it looks like all that stuff downloaded. I'm going to close the tabs, get out of that Firefox. That should be all the stuff we need. So if I go into my downloads folder now, I should see the three things that we needed to download, which are Anaconda, the CUDA base libraries, and the specific CUDNN libraries that enable deep learning. And now we're good to go. I think for now, I'm actually going to go back. It's probably a little bit easier to see. Well, no, actually, I was going to say I was going to go to the Mac terminal back here, but I may as well just keep it going on the virtual desktop. So you can do it either way. Some of this stuff I'm going to have to do through SSH because basically the CUDA installer will not work in a graphical environment. So you have to kind of reboot your system in text-only mode. But we are not quite there yet. So here we go. All right. So the first thing we can download that's pretty straightforward is the Anaconda thing. So I'm just going to do sudo bash the Anaconda. So bash is our command line interpreter. You may not, strictly speaking, have to put in the bash part, but I'm gonna, just in case, gonna go through the license agreement, yada yada yada. Okay, oops, there we go. And yes, I will accept those license terms. Okay, so I'm gonna actually not use the default location because that's wanting to go to just me. I'm gonna put it in opt Anaconda 3. Opt is a good place to put stuff that everyone on your system can access collectively, where I don't think on Ubuntu systems that anything is installed in opt by default. So that's a good place to dump all of your specialized deep learning software. This should go pretty quickly. There is a lot of stuff in Anaconda, but we got this pretty nice SSD in there that's pretty speedy. So all of our installs should go faster than they would on a conventional hard drive, at least. Like I said, what this is going to do is basically install like this base Anaconda environment, as well as a bunch of common Python packages, that are useful for scientific computing and all that kind of stuff. We can also install more packages, which we will need to do later. And again, the kind of advantage is that we can install these packages and configure them and do all kinds of crazy stuff. And it's still not affecting the sort of base, plain vanilla system Python installation, which is useful if you don't want to screw with the kind of base Python that came with your system. Again, if you're not a Python person, this may not make any sense to you, but Python's a little bit weird with like the toolboxes and everything that you can install alongside of it. And so you want to be a little bit careful not to get too much junk in your Python pathway that could interfere with each other. Okay. I will say yes to this, but actually I'm going to nullify this again later for reasons I will explain at that time. I will go ahead and install Visual Studio Code. I have not actually used it on Linux yet, but I like it okay on some systems. I don't intend to use it very much, but why not? Okay, so this will just take a few more seconds. The next thing we're going to do after this is install CUDA. And that's the thing that I said we can't really do in any sort of graphical environment, either from the computer itself or from one of these VNC virtual desktops. All right, looks like everything installed successfully, so yay. So the thing that we're going to have to do now is reboot this system in a fully non-graphical mode. So what I'm going to do here is I'm going to get out of my terminal. I'm going to close this. If you've not used VNC before, one thing to note is I have not killed this desktop session, right? So I can go back to my VNC viewer and I can just reopen that desktop. So this is the nice thing, right? Is I can have this session running, do something like that. List downloads. I can close this window and the session does not go away, right? Like my window into it has gone away, but that's still running on Bender. So anytime I want to log back in, look, there it is again, right? So that's what's great about VNC. However, can't use it for this next step because, like I said, you have to be in fully non-graphical mode to do the CUDA setup. So I'm going to go back to my SSH session, which is still running back here in the terminal, and I'm going to run the command that should make our system start up in text-only mode when we restart, which is systemctl set default dash user.target sudo system. I usually copy and paste these, but I want you guys to see them, so I have to double check I don't get typos in here, and enter my password again for the sudo. All right, so that has basically what that's basically said, and again, took us a little while to figure out exactly the right invocation for some of this stuff that made CUDA happy. But anyway, what this will do is ensure that when we reboot the system, it will reboot in a mode that does not allow graphical interfaces to run at all, and that's what we want. So now what we're going to do is reboot the machine, and I'm just going to issue the command to shut it down immediately, which does require sudo privileges. And basically that's going to kind of insta-force the machine to reboot. I mean, it does minimal kind of cleanup and everything, but basically reboots pretty quickly. And we just have to wait a few seconds, and then the system should be up and running again for us to log back into it, because you can see that it closed my SSH session. So once that's rebooted, we will basically run the CUDA installer. So let's see if it's up and running. Not quite. Oh, it just came up. All right, so here we go. All right, so here I am back in Bender. Doesn't look any different here, but if I tried to run a graphical session, which I will not try to do, that would probably fail. So instead, I'm just going to go straight to my downloads, do this all in text mode. I'll make my window nice and big. Oops. That's fine. Make my window nice and big so you can see better. Okay, so now we're going to run the CUDA installer, which looks a little something like this. So I'm just going to sudo Actually, you know what? One thing I have to do that I don't think I did yet. Yeah, so I'm just going to have to make this an executable file. Basically, I mean, there's various ways you could do this, but basically what that is going to do, if you've not done this before, chmod basically changes like privileges and stuff. What I basically did is I made this file executable, which means I can run it as a command. And I made that executable for both myself and other people on the system. The details do not matter too much. But anyway, that's going to let me do this, which is basically going to run that CUDA installer that I downloaded. Hopefully I typed my password correctly. I think I did. It's just, yeah, just taking some time to load. Okay, read the license agreement, blah, 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 blah. I'm actually going to skip it to the end because I've seen it all before. I accept that. Do I want to install the driver? Yes, I do. Do I want to install the OpenGL libraries? I'll just hit enter because the default's yes, and I do. I do not want to run NVIDIA Xconfig because I'm not going to use this graphics card as a graphical, like to drive any graphical display, so I'm not going to change my graphics configuration. I do want to install the CUDA toolkit. I will take the default location. I do want to install a symbolic link at user local CUDA, which is nice if you have multiple versions installed. I would like to install the samples, and this is what we've been using, although we don't really use the CUDA samples that much, but we've been putting it into opt CUDA underscore samples. Again, that's just so everybody can see it equally. It doesn't have to live in my home folder. And then it's just going to run. And if I successfully booted this thing into text-only mode, then this should succeed. If the system were not running in text-only mode, this would have failed pretty quickly. So I think we're in pretty good shape here. Okay, so we'll just take another minute or two. It's installing a gig or two of stuff, so it does take a little while here. But once that's done, if that says it has success, that's a pretty good sign. Okay, yep, this is all fine. Don't worry about the missing libraries. We will install some more libraries soon, but that's all fine. Okay, so that's good. Now the next step is to install CUDNN, which is, like I said, kind of the specific CUDA library that lets us do neural network stuff. I got to unzip that first, so let's see if I can do this by memory. I think that's the command to extract a TGZ file. And what this is going to extract is basically some library files. It's a little bit funky how this works, but basically what you're supposed to do is copy these into the CUDA directory. So like here, I'm going to go into the... So what I just unzipped here was this CUDA folder, so I'm going to go into that. There's a text file, but whatever. So what I've got here, though, are include and lib64 directories. And what you'll see is that, oops, sorry. All right, so if I look at the user local CUDA directory that I just installed, that also has an include directory and a lib64, but the files that I have here in my, in my downloads folder, these are not currently in that directory, right? So what I'm going to need to do is copy those to the corresponding places. So I'll copy the include. There's only one file in the include, which is the cudnn.h, and I'm going to copy that to my user local CUDA include, and I can't do that because that's a protected directory, so I just have to do that with sudo, and now that's fine. And similarly, I'm going to copy everything inside lib64. Yeah, I'll just do star into user local CUDA lib64, and once again that's predicted, but if I do it with sudo, that should copy fine. You could also move it, I guess, because I don't really need the copy that's in my downloads, but I just copied them. So there we go. So CUDA should now have CUDNN installed within it. So that's good. There's a couple things. I am just going to copy and paste these from my notes file because it's a little bit lot to type. I'm going to add some, basically add some path information to my bashrc file. If you're not much of a Unix person, I apologize, but you know, this is stuff that's good to know if you're using Unix stuff. Bash.rc is basically the file that configures your bash, which is the program you're actually running when you are typing commands into the command line. That's like interpreting your commands, right? So one thing I'm going to do is I'm going to paste these couple little nuggets, which basically just adds the CUDA stuff to my search path, which basically means like it gives me access to commands that are in the CUDA directory. It also sets this environment variable, or this variable that other programs can access, called CUDA root, which just kind of tells them where all the CUDA files are. I'm going to do one other thing since I'm in here. I'm going to actually comment that out. This is added by Anaconda. We actually told Anaconda it could do this when installed, which is to add Anaconda to our path so that we could access the Anaconda commands. You would think you would want to do that, but there's actually a little bit of a conflict between one of the Anaconda programs and our virtual desktop setup. Actually, all of the XFCE, I believe, whether you're using it virtually or live. So I'm actually going to turn this off and only enable Conda or Anaconda once I'm logged into stuff. So what I'm going to do is just comment this out. If I need to get Anaconda back, I will just uncomment these. But actually, one thing we can usually do is just launch these manually. You just have to append the path to them. So anyway, don't worry about this for now, but I'm going to comment this out so it doesn't conflict with our graphical interface. Okay, so anyway, I think we're ready to go here. Save that, and then I think at this point we are ready to like re-enable the ability to have graphical modes, because presumably you do want to be able to use graphics on your system most of the time. So I'm going to do the opposite of the command I did earlier, and put a sudo in front of that just to make sure that works. All right, so that should set us back to like enabling graphical mode. Now we have to reboot the system again. Oops. Okay. Excuse me. So we're just gonna give it a second to reboot. We're getting there. We're not quite 100% there. So we've done most of the hard installation stuff. Let's see if the system is up. No, not quite. So what we're going to do next is, we'll restart our VNC server so we can see things a little more graphically. So now we have to install a few more of our specific toolboxes. You know, the CUDA is kind of the most back of the back end levels of our sort of software hierarchy, right? So we've installed the basic CUDA stuff, but we still have not installed the specific toolboxes that deal with deep learning. So what I'm going to do is, first of all, get my VNC server running again. Let's see, I think I did 1280 by 800. Let's turn that up. I'm going to unminimize or unmaximize this. Go back here and bring back my VNC server program. Sorry, my VNC viewer program. Okay, so launch Bender again. Hey, there's my desktop. Hooray. The desktop does not get, well, I killed the desktop anyway, but the desktop does not get saved when you reboot or anything. So, you know, it's not like it preserves its state across reboots, but it's still nice to have. And we don't really ever shut our systems down if everything's going well. So I just leave mine up for months at a time. Okay, so now I'm basically going to still stay in the command line, but now I have a graphical desktop, you know, within the system if I do want to look at anything more graphically. All right, so now we gotta install our backends. So the first thing I'm going to install is Theano. As we've said elsewhere, possibly in this thing, Theano is one of the backends that Keras can use. It's actually like not under active development anymore. It's still the one we have been using. TensorFlow is a little bit more of a pain to set up, so that will be a separate discussion. But I'm just going to go ahead and install Theano. And to do that, I'm going to actually use pip. And I'm going to use the version of pip that Anaconda installed. So pip is like the Python package manager if you haven't used that before. And that's going to, since I'm using the Anaconda pip, that should install Theano into my Anaconda copy of Python. So that will kind of stay separate from my system Python. And I'm going to do, so that installed Theano, yay, that worked. I'm also going to install Keras the exact same way. This should get us the most recent, released versions of Theano and Keras. And I'm going to use a slightly different command. Pip doesn't do this other command, but Conda or Anaconda has it. So I'm going to install PyGPU, which the more recent versions of Theano and possibly TensorFlow. I'm not sure about TensorFlow, but Theano definitely requires it. So just going to install PyGPU. That should be fine. This is telling me what all packages Anaconda is going to install. And so that's all in there. Should be all good to go. One other thing I'm going to go ahead and install that I just realized we haven't installed yet. I'll technically use this here today, but I don't understand why Ubuntu systems come without Git installed. But if you're doing any software development on here, you're going to probably want Git. So that's what we use to track all of our stuff. Okay. So now we're almost there, I promise. A few more things we're going to do. So I'm going to make a file in my home directory. This is something each user of the toolbox will want to do separately for themselves. It's called .theano.rc. If you're using Theano backend, if you're not using the Theano backend, then you don't need to do this. And I'm going to actually copy this and paste it from my Mac. Oh, you know what? I can't copy and paste it from my Mac just yet, because what didn't I run? That thing you got to rerun every time you reboot the system or restart the VNC server. Okay, so now if I copy this thing, I'm just going to copy this from my Mac to make it a little bit faster to copy and paste. Oops. Maybe I'm not. Let's try this again. Use the wrong command, the wrong shortcut. Keyboard shortcuts do not always translate, of course, between Linux and the Mac, and my fingers get ahead of themselves sometimes. Okay, so this is basically your configuration for Theano. Some of the stuff you can change. I won't get into all the details right now, but this is saying basically to do all floating point calculations as 32-bit floats, so that we'll use 4 bytes per value, which should be plenty for most purposes. The device, this may change between systems. It's going to be CUDA 0, which should on this system be the only, basically it's saying like that's the first CUDA capable device. It may go by other names on other systems, or if you have multiple GPUs installed, it might be CUDA 1 or CUDA 2 or something like that. But that's the configuration I'm going to use here. Again, we can talk more details about that later, but this should be a good basic configuration. The other stuff I'm not going to change, and again, that's stuff we get into elsewhere, but that's a basic Theano RC file you can use if you're using Theano. And then if you're, well, we are using Keras. We can't really get around using Keras unless you're using the DeLINEATE toolbox. Only to do PyMVPA stuff, and if that's the case, then you didn't need to do any of this stuff, but hopefully that's not a big deal. Actually, we won't install PyMVPA today, so maybe we'll cover that another time. Probably because I just didn't put it in my notes here to do that. But anyway, so if we're using Keras, which we will if you're using the DeLINEATE toolbox to do anything but PyMVPA, oops. Make a directory called .keras, and then edit a file called .keras, keras.json. And again, I'm going to kind of copy and paste from my Mac just to make life a little simpler. This is going to be a JSON file. You may remember JSON as being the native file format of DeLINEATE batch jobs as well. And let's see. This should be fine. I mean, again, we don't need to go into too many details using float32 here. Also, backend is Theano, but again, we could change that to TensorFlow. This will be important later on, but the image data format, but don't worry about it too much right now. But anyway, that's a basic keras.json, basic Keras configuration file. So that's all set. One other thing we definitely have to do before we run any deep learning, and I will be honest, I only medium understand what this thing does, but what you'll find is that for whatever reason, the system does not seem to recognize the CUDA libraries until you do this little business here. Don't worry about that warning, that's not a big deal. And it seems to forget that periodically. Certainly when the system restarts, you'll need to re-enter that command, or at least we have to re-enter that command. Maybe somebody out there knows how we can suppress that and make it recognize that directory automatically. But that's definitely something we have to do, and it might sometimes lose track of your CUDA periodically anyway. So we find ourselves occasionally having to just re-enter that anyway. I wish I knew more, but right now we just kind of do that little bit of voodoo, and that seems to work. Okay, so moment of truth. I think we have everything set up correctly now. So let's go to the DeLINEATE website. Go to the download page. As I'm doing this, the current version is 0.2b. Let's download a copy. Save it. Oops, I think that's saved by the time I quit Firefox. Okay, so go to my downloads. Yep, there's DeLINEATE release 02b, so I'm going to unzip that. So if we did everything right, which I'm not 100% on, but I think we did everything right. Here's our toolbox. So here's our toolbox files, and if everything is working exactly as I think it should, we should be able to run. Now, here's a tricky thing here. There's my Python, which is 2.7, right? That's the system default Python. But I'm going to actually run the Anaconda Python, which I installed under Anaconda, right? So this is the Python under which we installed all of our toolboxes, right? So I'm going to log out of that. So that's the one that I'm going to use, which is why I'm using a long path here. So with the Anaconda Python, which of course you can like set up an alias to make that a shorter name or whatever. With the Anaconda Python, I'm going to run delineate.py, and I'm going to run it on a sample job file called small CNN by subject. And if we cross our fingers and pray to our favorite deities, it should correctly recognize that we want to run on the GPU. Yep, the GeForce 1080 Ti. And it should run nice and fast. It might take a minute or two to do this part, which is kind of a CPU bound process where it kind of compiles the model it's going to use by the CPU. If we look at our processes right now, we should see that Python's taking 100% of one CPU. Unfortunately, this process does not seem to be multi-threaded, but once it's done doing that, it should run the actual classification pretty quickly. Not well, partly just because this is a pretty simple classification we're doing, but also because we've got a pretty good GPU in here. So one thing you can do to check that your GPU is running or not is this NVIDIA SMI command. I'm just running this in a separate, actually, here's something I can do. Let me actually close this here, open up a second window, just to keep things cleaner, and run the NVIDIA SMI, which will give you basically a graphical or a sort of text-based graphical table of all of your GPUs, which for us is just the one, and what processes are using it. Now it looks like, oh look, okay, yeah. So now it has started running the classifications in Keras and with the DeLINEATE toolbox. It's running, pretty quickly here. And what we should be able to see here is that, if we just weren't sure that our GPU was being used, we could go to this NVIDIA SMI and we can see basically the memory usage. We can see that some process is using, 1,823 megabytes of RAM out of the 11 gigs that the 1080 Ti has on it. And we're using, at that moment in time, we were using 18% of our GPU, but that changes if I just enter this a bunch of times. That will change a lot depending on the exact instant, because sometimes it's, when it's 0, it's probably loading new data into the GPU to classify on, so it's very low utilization, but then when it's actually classifying, it should be near 100%. So anyway, there we go. So that looks like it's actually all set up and running. So hooray, we have successfully set up
a new Ubuntu system in only, I don't know, an hour or two, something like that, total time. Of course, in reality, if you were doing this from square one, it might take a little bit more effort than that, but you'll eventually get there. So anyway, that's a basic idea of what it takes to get a basic setup going. So we may cover some of these other kind of side topics like setting up PyMVPA, setting up TensorFlow as opposed to a Theano backend, but that's roughly what it will take to get one system like the ones that we have configured here set up for your own usage. So hopefully that was helpful for you. I will probably in just a second just log back into to Bender physically just to prove to you that we haven't screwed anything up on that end if you want to interface with it on the desktop. But for now, what I'm going to do is cancel that job. I'm going to close my VNC window. Although, again, the session hasn't gone away, right? I can always log back into VNC instantaneously. And just for good measure, I'm going to go ahead and cancel out of my SSH session to Bender. And I will quit my screen recording and say goodbye to you once I'm back over at Bender physically.
Okay, so here we are back at the physical embodiment of Bender, and hopefully, if everything is going well, I should be able to log into him and run analyses on him as well. One thing I'm going to do is change my default desktop environment, because once I've used XFCE to log in with my virtual desktop, it gets very ornery about using the Ubuntu default desktop manager. So I am committing to an XFCE lifestyle basically when I use that for my sorry. Let's see if that worked. A little hard to do this while recording on the smartphone. Okay, good. So here we are again. This, you'll notice that if this is not clear, like you can use VNC to actually view your session that you used to log into the machine, but we were running before an entirely virtual VNC session, right? So I'm not logging back into the VNC desktop I had running before. I'm logging into a new desktop session, although I always could go back to my Mac and log into my virtual desktop as well. So those two things could be going simultaneously. But anyway, if I want to prove to myself that deep learning works on the desktop as well, not just on that, let's go to downloads and delineate. So that's in my downloads folder there. Now if let's see if I can, no, it doesn't have that in my command history because I had multiple windows open. So let's just do, let's see if I can do this easily. Opt Anaconda 3 bin, and again you can like alias this to something more convenient or do lots of other things. If you never want to use VNC, you can just leave the Anaconda paths as it was, and that should work fine on the default Linux desktop. It just kills XFCE for some reason. Okay, so let's see, but with my weird workarounds, that's what we have to run. And then we'll run the easiest part of all of this, which hopefully you now appreciate, is actually our toolbox, right? All we have to do, once you've got all the backends set up, our part is actually pretty simple, right? We just run Python with delineate.py, and we run whatever sample file we want. We'll run the same sample job file again. So that'll be the small CNN. And moment of truth. We're getting some warnings, by the way, about future compatibility and stuff, but it looks like that is successfully running on the GPU. Otherwise, it would give us some kind of error or warning message that it couldn't find the GPU. And if I go to a new desktop and do that and do NVIDIA SMI over here, I should be able to see that I might have to do it a few times to catch the GPU being used, but there you go. So yep, still has an 1823 megabytes loaded in, which is about the size of our data set and model that we're running over there. And it's running, at that particular instant, it was running at 80% utilization, which, should be what it's doing. So looks like it's all running well, both on the, physical login here, sitting right at the machine, and also through a virtual desktop. So that's the basic setup. Thank you for bearing with me. Hope this was informative. Good luck with your own installs, and we'll catch you on the flip side. Bye for now.